Welcome to this tutorial. In this tutorial, I will be explaining how the different images are made using a thin lens, the converging lens, or it is also called the convex lens. For this demonstration, I have taken a lens, and this lens has a focal length of 2 centimeters. So here is the point of 2 centimeter, which is the focal length of this lens. On the other side, this 2 centimeter is the other principal focus. Similarly, 4 centimeter would be the point where the 2f is lying on both sides of the lens. So I'm starting by placing my object beyond 2f. So when the object is placed beyond 2f, since it is placed beyond 4 centimeters line, the image is formed between f and 2f on the other side of the lens. So it is being formed between 2 and 4. Secondly, the two rays coming from the top of the object. One is going parallel to the principal axis, and after being refracted, it is going through the principal focus 2 centimeter point. The second ray is coming from the top of the center and going through the center of the lens and going undeviated after being refracted from the lens. Where the two rays are meeting, the real image is being formed, which is diminished and inverted, but it is a real image being formed on the other side of the lens. Now in this second situation, I've moved the object at 2f. So we can see that the image being formed on the other side of the lens is also positioned at 2f. The image being formed is real image because the real rays of light are meeting. The first of the ray is similar to the previous one. It is the ray which is coming parallel to principal axis and after being refracted passing through the principal focus. The second ray is coming and passing through the center of the lens and continuing its path undeviated. The two rays are meeting exactly at 2f and the image being formed is inverted, real, and of the same size as the object. Now when I move the object between f and 2f, for example at 3 centimeters, we can see that the image is now being formed beyond 2f. Real image is being formed because the ray coming parallel to principal axis after being refracted, it is still passing through the principal focus as it should pass. The second ray coming from the top of the object is passing through the optical center or the center of the lens and it is continuing its path undeviated. The two rays are intersecting each other and a real image is being formed. This image is magnified as we can see. It is inverted and it is a real image. Now, when I place my object at the principal focus, both rays, after being refracted from the lens, become parallel to each other. So we say that these rays are going to meet at infinity and a real image, very magnified image, is going to be formed. Once the object is moved within the principal focus, for example, if I move it at 1 centimeter, now all the images formed after the object is moved within the focal length are going to be the virtual images. The first ray, which was coming parallel to principal axis, is now refracted and going through the principal focus. The second ray still is continuing its path undeviated. The two rays are moving away from each other. They are not going to intersect each other at any point. But if we trace back these refracted rays, they seem to be coming from a point. And this point lies on the same side of the lens as the object is placed. So on this point, a virtual image is formed, and this image is, as we can see, a magnified image, and it is not inverted, it is erect image. So this is how the different images are formed using a thin lens, the convex lens. And we saw that when the object was placed beyond the focal point between f and 2f or at 2f or beyond 2f, real image was being formed and it was being formed on the other side of the lens. And when we move the object within the focal length, the virtual image has started to be formed. And in this situation, the convex lens is acting as a magnifying glass. So this is how the different ray diagrams and different images are formed using a convex lens.